Here question is calculate the H11 for the circuit shown below. Here the definition for the hybrid parameter H11 is nothing but V1 by I1 and V2 equals to 0. That means input impedance we have to calculate. But see, input side it is short circuited, means V1 is nothing but a 0, hence H11 is 0. Hence option A is correct. Here the question is a network having 4 branches and 2 nodes. Calculate the number of fundamental cut sets possible. We know that this is a question from the graph theory where number of fundamental cut sets equals to the number of nodes minus 1. Here the number of nodes are n. Here n is nothing but a 2 here, so 2 minus 1 is 1. Hence option C is correct. Question is calculate the Thevenin's resistance seen by the terminals A and B. That means we have to calculate the impedance of the network when we are looking from the input side. That is, if we consider this one is I1, then the input impedance is nothing but, or Thevenin's impedance is nothing but V1 by I1. So if we apply the KCL at node C, that is minus I1 plus 2V1 plus V1 divided by 2 ohms equals to 0. This is the parallel combination of this is nothing but a 1 ohm. So I1 equals to 2 plus 1 by 2. This is V1. Here V1 by I1 is nothing but 5 by 2 V1. That is 2 by 5.4 ohms. Hence option D is correct. Question is when a plane wave is incident normally from dielectric whose relative permittivity is epsilon 1 onto a dielectric 2 whose permittivity is epsilon 2. The electric field of the transmitted wave is minus 2 times the electric field of the reflected wave. Then the ratio of epsilon 2 by epsilon 1 is. Here epsilon, that is transmitted electric field, is nothing but 2 times the reflected electric field. So ET by EI is nothing but minus 2ER by EI. We know that ER by EI is nothing but reflection coefficient, that is gamma, whereas ET by EI is nothing but transmission coefficient, that is 1 plus gamma, which is 2 eta 2 by eta 2 plus eta 1, whereas ER by EI is eta 2 minus eta 1 by eta 2 plus eta 1. Eta is nothing but intrinsic impedance of a dielectric 2, whereas eta 1 is the intrinsic impedance of the dielectric material 1. So eta 2 is nothing but mu naught mu r. Eta is nothing but mu naught mu r by epsilon naught epsilon r. Okay, so if we substitute those things, that is 2. So after cancelling, because all the material we are assuming that the dielectric 1 as well as the dielectric 2 both are non-magnetic materials. That means mu r is going to be a 1 and mu naught is same for all the both dielectrics. So from that one, this is equals to 1 by here, this is epsilon T by epsilon I is this, means 2 eta 2. Okay, here is minus 2, gamma is this, So these two gets cancelled. This gets cancelled. 1 by root epsilon 2 is nothing but 1 by root epsilon 1 by 1 by root epsilon 2. So root epsilon 2 minus root epsilon 1 divided by root epsilon 1 root epsilon 2. This case cancelled. Root epsilon 1 is root epsilon 2 minus root epsilon 1. So 2 root epsilon 1 is root epsilon 2. From this, epsilon 2 by epsilon 1 is 4. Hence option D is correct. A transmission line has primary constants or LGC and the secondary constants Z0 and the propagation constant gamma. Gamma is equals to alpha plus J beta. Alpha is the attenuation constant, beta is the phase constant. If the line is lossless, then here propagation constant is alpha plus J beta, which is also equals to R plus J omega L G plus J omega C. Okay. If the line is lossless means for the line to be lossless R G must be 0. Then gamma equals to J omega under root LC, which is nothing but 0 plus J beta. If we compare here, real part means real part is 0, imaginary part is J omega under root LC. So alpha equals to 0. Magnitude of the propagation constant is nothing but beta. R equals to 0, Z equals to 0. Hence D is the only option which is correct here. Hence option D is correct. Is input impedance of the short circuited lambda by 4 long transmission line is. Okay. We know that if the length of the transmission line is lambda by 4, that means this length is lambda by 4. Here if it is terminated with ZL, whose characteristic impedance of the is Z0, if we look from here, this is the Zin. Okay, Zin is nothing but Z0 square by ZL for the lambda by 4 length transmission line. From the question, ZL equals to 0. That means Zn is going to be infinite. Hence option D is correct. Question is, the output voltage V0 of the circuit shown below is. Okay. See here, first of all, in order to decide V0, we need to decide the conducting state or the state of the diode, whether it is conducting or non-conducting. Here the conduction of the diode is decided by the node potential VA. That is, if we assume the diode is ideal, 10 minus VA should be greater than 0, then only the diode is going to conduct. So for that one, what we have to do is, first of all, we have to find out the VA without diode. So remove the diode, then it is going to be open circuited here. So because of 10 volts, nothing will be resulting at node VA, but because of 24 volts present here, there is a voltage VA is developing here. So VA is nothing but 24 divided by 40 into 20, which is nothing but at 12 volts. So 10 minus 12 is not greater than 0. It means the voltage across the diode is a negative, hence it is not going to conduct. It is in off state. As long as it is in off state, the potential at node VA is because of 24 volts, that is half, that is 12 volts.